Okay, for this warm-up, we're just practicing reducing rational expressions. So we want to look at any numbers that are involved and then any variables that are involved or any factors that are involved in general. So this first one, 45x over 25x squared. First thing to always check is it factored? There's nothing we can factor here, so we're good in that instance. So now we can look at, first we'll check out our numbers. So 45 and 25. They both end in 5, so I know 5 divides both of them. So we can reduce them that way. 45 divided by 5 is 9. 25 divided by 5 is 5. So we know 45 over 25 can reduce to 9/5. And if you aren't sure how they reduce, use your calculator to help you out. Even use Desmos has a way where you type in 45 over 5 and click the fraction button, and it will help you out as well. And then we want to look at the variables. So x over x squared. Technically what that means is we have 1x on top, 2 x's on the bottom multiplied together. So that means is we can cancel an x out of the top with an x on the bottom. We're left with just 1x on the bottom. So that square goes away. It cancels out with the x. So that in reduced form is 9 over 5x. This next one is now we're getting into more complicated expressions. And notice there's pluses and minuses in here without any parentheses. So these need to be totally factored first before we can cross anything out. So we need to use our box to help us factor. This top one, b squared to negative 30. And then numbers that multiply to negative 30 and add to positive 1 would be 6 and negative 5. Pull all of our factors out. So we know the top factors to be b minus 5 and b plus 6. And now the bottom, this one only has 2 terms in it, so we can't use the box to help us out. But we can take a GCF out of there. 3 goes into both of those, and also a b goes into both of those. If we divide that out, the 3 totally divides out, and then the b squared would be left with 1 singular b, and then 18 divided by 3 is 6. The other b comes out front. When you're doing that GCF, remember, a way you can check yourself, so we just said that was 3b times b plus 6. Make sure if you redistribute, it would be the same thing. So 3b squared plus 18b, that's indeed what I want it to be, so that checks out. Once we factor it, now we can go and reduce. So if we look at this, there's a b plus 6 on the bottom and the top. Since that entire factor is exactly the same, it can be canceled out. So this one reduces to b minus 5 over 3b. We cannot do anything with the b on the top and the bottom there because of that minus 5. So it only works if the whole factor in itself is the same. A couple more here. This one with the v's. So we don't have any squares to deal with in here. And there aren't any 3-term ones. So this isn't going to be a box deal. Really, we just need to look for that GCF because there are 2 terms up top. So something that divides with 56 and 72. And play with that. In this case, I know 8 divides both of those. So 8 goes into 56 7 times. 8 goes into 72 9 times. And then over 32v. Now that it's factored, we can look at, we have this 8 out front and this 32. Those can reduce. So again, you have to factor first, then you can go about reducing. 8 goes into 32 4 times, so that will reduce. We can divide each by 8. So 8 divided by 8 is 1. 32 divided by 8 is 4. So this one in fully reduced form would be 7v minus 9 over 4v. Again, we cannot cancel those v's out due to the fact that there's that minus 9 up top. And that v is connected in the phrase to that minus 9. So those cannot cancel. Okay, last one. This is just another one where we have factor first. The top, nothing we can do with. The bottom, though, is a trinomial. So that's 3 terms, which means we can factor it with our box. Numbers that add to negative 7, or multiply to negative 7, but add to positive 6 would be a 7 and a 1. Pull out our GCFs. Oh, that'd be a negative 1. Whoops. There we go. So this factors. Top stays the same. Bottom turns into a plus 7 and a minus 1. Again, these cancel out. Now notice, I canceled out everything on top, but that a minus 1 still has to stay in the denominator. It doesn't suddenly become the only thing in the fraction. So what we're left with on top is technically a 1. Because really when they totally cancel out, they both turn into a 1. So we end up with 1 over a minus 1, and that's how that one factors. So today we're going to get into dealing with how do these canceled factors affect the graphs of rational functions.